Hey everyone, welcome to Crazy Calculations, and for today's Crazy Calculations, we're going to be learning about the properties of exponents. So these are all of the properties that I'm going to be going over today, and if you ever want to skip around in this video, all of the timestamps can be found in the description down below. So let's get started. First is power of 1, and it states that any number to the power of 1 is just itself. So 3 to the power of 1 is 3, negative 8 to the power of 1 is negative 8, and 762 to the power of 1, you guessed it, 762. Power of 0. And basically anything to the power of 0 is just 1. So 5 to the power of 0, 1. 11 to the power of 0 is 1. And negative 53 to the power of 0 is 1. What a surprise. And also, 0 to the power of 0 is not 1. Okay, it's not 1. Well, why does this work? Think about this. What is 7 cubed divided by 7? That's 7 squared, right? And what's 7 squared divided by 7? That's 7 to the power of 1, right? So shouldn't 7 to the power of 1 divided by 7 be 7 to the power of 0? And what is 7 to the power of 1 divided by 7? That's just 1, right? And I'm just picking 7 for this case, but this works with any other number. Next is negative exponents. So when you have a number to a negative exponent, I don't want you to think of this as a to the power of negative m. I want you to think of this as a fraction. So, a to the power of negative m over 1. It's the same thing, but written in a different way. And what you're going to do to get rid of this negative exponent right here is you're just going to take this whole thing and you're going to put it in the denominator, which gives you this. Or if you have 1 over a to the power of negative m, so it's in the denominator, the negative exponent, you're just going to put it in the numerator. So this equals a to the power of m over 1. So, if you have 3 to the power of negative 1, to get rid of this negative, first we're going to think of it as a fraction. So that's 3 to the power of negative 1 over 1. And to get rid of the negative, you're just going to put it in the denominator. So you get 1 over 3 to the power of 1, and you get 1/3. Similarly, if you have 1 over 2 to the power of negative 3, your negative exponent is in the denominator. So what you're going to do this time is put 2 to the power of 3 in the numerator, which gives you 2 to the power of 3 over 1, which is 8. And why does this property work? Well, just like how we said last time, 7 to the power of 1 divided by 7 is 7 to the power of 0, right? So shouldn't 7 to the power of 0 divided by 7 be 7 to the power of negative 1? And what is 7 to the power of 0 divided by 7? That's 1 divided by 7, right? Which is 1/7. And shouldn't 7 to the power of negative 1 divided by 7 be 7 to the power of negative 2? And what is this? Well, that's 1/7 divided by 7, which is 1 over 49. And 1 over 49 is the same thing as 1 over 7 squared. Fraction exponents. So if you have a number to the power of a fraction, what you're going to do is treat the numerator just like any normal exponent, and you treat the denominator like a root. And it doesn't matter whether you use the exponent first and then take the root, or if you take the root first and then use the exponent. So if you take 7 to the power of 1/2, this 2 acts as a square root, so you get the square root of 7. Or if you have 5 to the power of 2/3, the 2 just acts as the normal exponent, and the 3 acts as a cubed root. So you get the cubed root of 5 squared, which is the cubed root of 25. Or if you have 7 to the power of 4/6, just like any other fraction, you're going to want to simplify this first, which is 7 to the power of 2/3, and the 3 is a root, the 2 is a normal exponent, so you get the cubed root of 7 squared, which is the cubed root of 49. Now, how about 8 to the power of 4/3? Well, the first thing I think when I see this is I have a cube root right here, and I know 8 is a perfect cube, because 2 cubed is 8. So, I'm going to take the cube root first to give me some smaller numbers, so I get the cube root of 8 to the power of 4, which is 2 to the power of 4, which is 16. I could do 8 to the power of 4 first and then take the cube root, but that gives me bigger numbers, so I wouldn't want to do that. Alright, the next property is power of a power. And this works when you have a number to the power of something, and then that whole thing to the power of something else. And what you're just going to do is you're going to have that number to the power of the two exponents multiplied together. So if you have 3 squared to the power of 4, that's 3 to the power of 8. If you have 5 to the power of 3 to the power of negative 8, that's 5 to the power of negative 24. And if you have 2 to the power of negative 7 to the power of negative 5, two negatives make a positive, so you get 2 to the power of 35. And why does this property work? Well, take 4 cubed squared, for example. What is 4 cubed? That's 4 times 4 times 4, right? When you square that, you multiply this by itself, which means you have 4 times 4 times 4 times 4 times 4 times 4. And when you condense this as a number to an exponent, you get 4 to the power of 6, right? Because you have 3 from here, and then double that from this exponent. Next property is the product property. The product property is when you have a number to the power of something times that same number to the power of something else. Or this could be the same thing as this. It doesn't really matter. And it gives you that number to the power of the two exponents added together. So, if you have 5 cubed times 5 squared, 3 plus 2 is 5, so you get 5 to the power of 5. If you have 3 to the power of negative 5 times 3 to the power of 3, you get 3 to the power of negative 2. You just add these two exponents together. And why does this property work? Well, take 5 cubed times 5 squared, for example. 5 cubed is 5 times 5 times 5, and 5 squared is times 5 times 5. So total, you get 5 times itself 5 times, which is 5 to the power of 5. You have 3 here and 2 here. Next is the quotient property. And the quotient property is sort of like the product property. It's when you have a number to the power of something divided by that same number to the power of something else, and you get the number to the power of the exponent in the numerator minus the exponent in the denominator. So if you have 4 to the power of 9 over 4 to the power of 5, 9 minus 5 is 4, so you get 4 to the power of 4. If you have 8 to the power of negative 3 over 8 to the power of 4, negative 3 minus 4 is negative 7, so you get 8 to the power of negative 7. If you have 6 to the power of 9 over 6 to the power of negative 2, 2 negatives make a positive, so you get 6 to the power of 11. And why does this property work? Well, think about 4 to the power of 5 over 4 cubed. When you write this out, you have 4 times itself 5 times in the numerator and then 3 times in the denominator. So you can cross 3 of these out because they show up in the numerator and the denominator, which leaves you with just 4 times 4 in the numerator, which is 4 squared. Next property is power of a product. This works when you have the product of 2 or more numbers all to the power of something. And basically you can distribute this exponent to each of the factors, so you get one of the factors to that power times the other factor, or factors to that power. So when you have 5y squared, this squared can basically distribute to the 5 and the y, which gives you 5 squared y squared, which equals 25y squared. Likewise, if you have 4xy all cubed, this cubed can distribute to each of the parts, so you get 4 cubed x cubed y cubed, which is 64x cubed y cubed. This also works with negative exponents. So if you have 3z to the power of negative 2, there's 2 ways you can approach this. The first thing you can do is get rid of the negative right away, so you get 1 over 3z squared, and then distribute the 2 like this, and then simplify, which gives you 1 over 9z squared. Or the other way you can do it is you can distribute this exponent first to get 3 to the power of negative 2 times z to the power of negative 2, and then put it all in the denominator, and then simplify. They both give you the same answer, but it's just 2 different ways to do it. And why does this property work? Well, think about 5y squared. What is 5y? That's 5 times y, right? And what does the squared do? It gives you 5 times y times 5 times y. So you get 5 times y, which gives you 5 squared y squared, which simplifies to 25y squared. And with this property, there's one thing that you need to remember, and that is, like how we just proved, 5y squared is indeed 25y squared. We just proved that, right? But, and this is a very big but, if you have 5y squared without the parentheses that you have up here, no parentheses, that means this squared is only changing the y, not the 5. So this definitely does not equal 25y squared. This is just 5y squared. That's it. And now we are at our last property, the power of a quotient. This is sort of like the power of a product property, but with a quotient. So it says when you have one thing divided by another all to the power of something, it equals the numerator to that power over that denominator to that power. So when you have 2 over 5 all cubed, that gives you 2 cubed over 5 cubed, which simplifies to 8 over 125. Like the last property, this also works with negative exponents. So when you have 2/5 to the power of negative 3, there's 2 ways you can approach it. The first is to flip it first to get rid of the negative, so you get 5 over 2 cubed, and then distribute the power of 3, so you get 5 cubed over 2 cubed, which is 125 over 8. The second way to do it is to distribute the power of negative 3 to the numerator and the denominator right away, so you get 2 to the power of negative 3 over 5 to the power of negative 3, And then you can flip the numerator and the denominator to get 5 cubed over 2 cubed, which gives you 125 over 8. Again, 2 different ways to do it, but they both give you the same answer. And why does this property work? Well, take 2 over 5 cubed, for example. 2 over 5 cubed is 2 over 5 times 2 over 5 times 2 over 5. And remember, when you multiply fractions, you need to multiply the numerators together and the denominators. And that gives you 2 cubed over 5 cubed. And that's it for the properties of exponents. If you have any questions, comments, videos you want to see, or anything else you want to say, feel free to drop a comment down below. And other than that, I will see you next time.